Hey everyone. Today I wanted to make a quick video on this photometry analysis program that I've been working on. If you do fiber photometry, then you know that the hardest step is really the analysis part. The surgeries and the recordings are pretty straightforward, but the analysis can be really difficult, especially depending on what system you have. So I have a Neurophotometrics system, and there's no built-in analysis software that comes with that. So I've had to kind of scour the web to find what's available. And a lot of the stuff that I found, including what I ended up putting in my program, this algorithm, a lot of these options require a little bit of a coding background. So I made a program which basically just takes this really nice data processing algorithm for photometry made by Katerina Marcinova and puts it in a GUI that's easy to use for anyone, regardless of their coding background. So you can basically use a tool like this without having to download and understand anything about Python or MATLAB or R. So if you go to my GitHub page, which is here, you can click down here at the Photometry Analysis Program, and it'll take you to this repository. And if you do have Python on your computer and you want to run this yourself, you can follow the steps, which are down here. But I'm going to show you how it works on my computer, just assuming that most of us don't have Python and maybe don't want to. So I'm going to run this program, and you'll see that it brings up a window here. It's really simple, nothing complicated. And just for a quick kind of demonstration, you can click this Load and Analyze Sample Data button, which was suggested by Chris Anderson. So thank you, Chris, for suggesting that. And if you click that, it'll run the analysis and pop up this new window with a plot in it showing you the ZDFF over time, right? So this is just supposed to act as kind of a quick check for you to look at your data and say, hey, does this look roughly right and reasonable? So if this looks reasonable to you, you could X out of this and then export that analysis. So we can call this whatever we want. And it'll ask you to pick a folder. So I'm going to put it in the downloads folder. And if we go look at that, we open up that CSV we just created, this whatever CSV. You'll see that if you work with Neurophotometrics, this output contains a lot of the columns that were in the original 470 file. So there's a frame counter, timestamp, but it added these two other columns. And this is really what the analysis is doing. So it's computing time based on the timestamps, and it's doing the multiple steps to compute this ZDFF for region 0G, which is just the region of interest, right? And so I have it output to the CSV because that's a convenient way for you to then use whatever visualization tool you like. You could plot this in Excel or whatever else you want to do, right? So it's really just applying that algorithm to compute the ZDFF. But that was just with the sample data, which kind of comes with the program. If you download it from my GitHub, there's the sample data right here. But now let's do it with quote unquote a real file. Right, so I'm going to pick a file with bilateral data. And so I'm going to go here, downloads. I'm going to pick the 470 writer for this bilateral file, 415 writer for this bilateral file, and the timestamps for the 470 for this bilateral file. And so this is a recording where I had an implant in the left hemisphere and the right hemisphere. So I have a region 0G and a region 1G. So now when I click Analyze, it'll pop up a window for each of those, right? Because this is one fiber on the left and another fiber on the right. And I can just kind of look at this and ask, okay, does this look reasonable? And if I'm satisfied, I can X out of these and then click Export. We could do bilateral. And we'll go to Downloads. And then if I open that up in the Downloads file, or sorry, in the Downloads folder, you'll see, just like the unilateral sample data we had, there's the original kind of data that was in the file we used as an input, but then the analysis step computed time, the ZDFF for region 0 and region 1. Right? So again, this is following the Neurophotometrics format. If you have a different system, this program may not work for you, but it was designed for people with Neurophotometrics. So this is the program as it's working right now. We're going to add this DIO step. So if you have like digital input output, like a lever press or something, some type of event, and you'd like to compute sort of a peri-event plot, we'll be able to do that. But if you think this would be useful for you or your lab, let me know. I'd be happy to share it and let me know what you think. So yeah, hope you like it. Talk to you later.